Through this video, we are going to discuss a previous university question from the topic Solution of Linear System of Equations. The question is, find the values of a and b for which the system of equations x plus y plus 2z equal to 2, 2x minus y plus 3z equal to 10, 5x minus y plus az equal to b has no solution, unique solution, infinite number of solutions. So the question is about to find the values of a and b. Let us see the solution. As usual, we will start with the augmented matrix AB obtained by using the coefficient matrix augmented with the right hand side column matrix. The task is to reduce this augmented matrix to the echelon form. For that, we first consider the first pivot element 1 and we have to make all the entries below that pivot equal to zeros by using the row transformation R2 to R2 minus 2R1, which will make this 2 as equal to 0. Then R3 to be transformed to R3 minus 5R1, which can make this 5 is equal to 0. Let us consider the first row transformation R2 minus 2R1. So this transformation is applied to every element of the row, and hence we have the first element reduced to 0. The second element is minus 1 minus 2 times 1. So minus 1 minus 2, it is minus 3. The next element is minus 1. The next element is 3 minus 2 times the corresponding element in the first row. So 3 minus 4, we have minus 1. Then the next element is 10 minus 2 times the corresponding element in the first row. So 10 minus 4, it is 6. Consider the next transformation R3 minus 5R1 applied to every element of the third row. So 5 minus 5 is equal to 0. And the next element becomes minus 1 minus 5 times corresponding element in the first row, and hence we have minus 6. Then we have a minus 5 times corresponding element in the first row, 5 into 2, so it is a minus 10. And the next element becomes b minus 5 times corresponding element in the first row, and hence we have b minus 10. So hence the second and third rows get transformed so that the element below the first pivot element are all converted to zeros. This matrix is still not in echelon form, and therefore we have to apply the elementary row transformations again so as to make this in echelon form. For that, we consider the next pivot element. The first non-zero element of the second row is minus 3. We have to make the entry below that minus 3 equal to 0 by using suitable row transformation. Remember, we don't have to do anything with the first row or the second row, because up to the second row everything is fine. We have to make the transformation only for this third row with respect to the current row, which is the second row. The current row is the second row. So the transformation is R3 minus 2 R2, R3 minus 2 R2, which can make this minus 6 equal to 0. And the same transformation is applied for every element of this third row, and therefore the next element is a minus 10 minus 2 times corresponding element in the second row. So 2 times minus 1. So it is a minus 10 plus 2, and hence we have a minus 8. The next element is b minus 10 minus 2 times the corresponding element in the first row, and hence we have b minus 10 minus 12, or it is b minus 22. And hence the third row is reduced to 0, 0, a minus 8, b minus 22. As such, this matrix is in echelon form, so we can stop at this stage. We proceed to finding the ranks of augmented matrix and the coefficient matrix, so that we can have the conclusions which leads to the answer to these three questions. So let us see what can be done in the next stage. Now the first thing is to get the values of A and B so that we have no solution to this system of equations. So, no solution to a system of linear equations means rank of AB is not equal to rank of A. Rank of AB is not equal to rank of A, then we say that the system has no solution or the system is inconsistent. See this echelon matrix. Now here, what happens if A is equal to 8? Let us see what happens if A is equal to 8. When A is equal to 8, this element will become 0. This becomes 0. And so when A equal to 8, let us see what happens. Rank of AB is equal to, when A is equal to 8, rank of AB is equal to 3 because we still have 3 non-zero rows, because I am not converted this B minus 22 to 0, or I have not set B equal to 22. B is not equal to 22. Let us assume B not equal to 22 and A equal to 8. Then in that case, we have 3 non-zero rows in the echelon form corresponding to the augmented matrix, and hence rank of AB is equal to 3. But when you remove this last column, what happens is we have only 2 non-zero rows. The third row as a whole becomes 0, and therefore there are only 2 non-zero rows, which leads to the rank of A as equal to 2. So in this case, there is a disparity between the ranks of AB and rank of A, and therefore we say that there is no solution. So in this case, we should have A equal to 8 and B not equal to 22. So this is a typical case where we have no solution. Hope it is clear. Now come to the next case. Come to the second case. In the second question, we need unique solution. We can have a unique solution when there is a common rank and when the common rank is equal to the number of unknowns. Number of unknowns is 3 because we have x, y, z as unknowns whose number is equal to 3. So for a unique solution, we should have the common rank is equal to 3. So common rank is equal to 3 means rank of AB must be equal to 3 and rank of A should also be equal to 3. When can this happen? So this can happen only when A is not equal to 8. When A is not equal to 8, this is a particular non-zero value, and we are not worried about the value of this last value. Even if it becomes 0, we do not have any problem because we have A minus 8 as a non-zero value, and as long as this A minus 8 is a non-zero value, we have the rank of AB as equal to 3 because we have 3 non-zero rows. And when you remove this last column, by keeping this A minus 8 as a non-zero value, still the rank of A is also equal to 3. So, rank of AB equal to rank of A equal to number of unknowns, and that leads to unique solution. And so, we write here B can assume any value. B can assume any value. B can assume 22 also. So no problem regarding the value of B, it can assume any value. Therefore, to have a unique solution, we should have A not equal to 8. In the third question, we have to see the system consistency with infinite number of solutions. You know, the system is consistent with infinite number of solutions when the common rank is less than the number of unknowns, when the common rank is less than 3. The common rank should be less than 3. So, rank of AB and rank of A both should be less than 3. When can this be happening? So, A should be equal to 8 and B must be equal to 22. A is equal to 8 and B is equal to 22. A equal to 8 means this A minus 8 becomes 0. B equal to 22 means B minus 22 is also equal to 0. So, the entire third row is 0. And therefore, we have only 2 non-zero rows in both AB and A, and therefore rank of AB is 2 and rank of A is also equal to 2. Therefore, the common rank is less than the number of unknowns, and hence we have infinite number of solutions. Thank you.